All right, today we're jumping into a really fascinating white paper. It's about a pretty radical new way to think about digital privacy. It's called Ghost Protocol, and it's all built around this wild paradox. What if the absolute best way to protect your data was to make sure it never even existed to begin with?
So here's how we're going to break this down. First up, we'll talk about that permanent digital trail we all leave behind, and we'll pinpoint the ultimate flaw in pretty much all of today's privacy systems. Then, we're going to dive into what this paper calls the non-existent solution, how it might be a way out. After that, we'll explore what this kind of power actually unlocks, and, you know we have to do this, we'll finish by getting real about the risks and where this tech is at right now.
Okay, so let's just sit with that question for a second. It sounds completely impossible, doesn't it? I mean, how on earth can you prove you have something without actually showing it to anyone? How can you own something valuable that doesn't technically exist on any public record? That's the mind-bending idea we're really going to unpack here. Okay, first things first. Before we can get to the solution, we have to really understand the problem Ghost Protocol is trying to fix. And that problem? It's this permanent and frankly super vulnerable digital trail that we all create every single day. I mean, just think about your own day. Every single time you buy something online, send a quick message, or log into a service, you're creating a data point. It's a permanent record. And these things, they just pile up and up, creating this massive, detailed history of your life that can be leaked, stolen, or even subpoenaed. This is the baseline problem, the starting point for any privacy system out there. And that leads us straight to what this white paper calls privacy's ultimate flaw. See, it argues that almost everything we do for privacy right now, from those we care about your privacy policies to really complex encryption, it all shares the exact same fundamental weakness.
And this is the absolute key. Hidden data can always be unhidden. Always. If you have enough time, enough computing power, or just a court order, what's hidden can be revealed. And why is that? It's simple. Because the data still exists somewhere. It's just sitting there, waiting to be found.
So you can kind of think of data protection as a hierarchy, right? A ladder. At the bottom, step 1, you've got policy. That's really just a promise, and we all know promises can be broken. Step 2 is access control. Think passwords and firewalls. Better, but those controls can be bypassed. Then you get to step 3, encryption. This is powerful stuff, but it has an Achilles heel. The keys can be stolen. Ghost Protocol is trying to create a whole new level. Step 4, non-existence. A state where there is literally nothing left to access, nothing to decrypt, and nothing to steal. So the big question is, how do you actually achieve this state of non-existence? It sounds almost philosophical. Well, let's get into the nitty-gritty of how the Ghost Protocol solution actually works. This right here is the core philosophy. It's a total shift in thinking. It's not about making your data secret. It's about making it, for all practical purposes, non-existent in any form that someone could attack. The goal isn't just to build a taller, stronger wall around your treasure. The goal is to make the treasure itself invisible.
This chart does a great job of showing the difference. Okay, look at encryption. Its whole principle is to conceal data. It creates unreadable ciphertext. But the vulnerability? The key can be stolen. And the future risk? Well, future technology, like quantum computers, might be able to break it. Now look at Ghost Protocol. The principle isn't to conceal, it's to eliminate. It doesn't create ciphertext, it creates a cryptographic proof. There's no key to steal, which is huge. And the future risk? Well, there's no data to decrypt in the first place. Game changer.
And this is the core guarantee that, honestly, changes everything. You can prove to a system that you have something real, a token, a credential, maybe a vote, without ever showing the data itself to that system. So it's provably real. You can use it, but it's also provably inaccessible to literally everyone else. It's a real paradox, but it's a powerful one.
Okay, so how does this work in practice? Let's walk through the first life cycle path, commit to reveal. This is the happy path, let's call it. First, you create a commitment. You can think of this like a cryptographic hash, basically a unique digital fingerprint of your secret. That's step 1. Then step 2, that commitment gets recorded publicly, on-chain. Now, when you want to use it, you go to step 3. You present your original secret. The system then does a quick check in step 4. Does your secret match the public commitment? Yes? Great. It marks that commitment as used or revealed, and it can only be done once. That's it.
But what about the second path? This one's just as important. It's commit to silence. So you do the same thing. You create a commitment and you record it publicly. But this time, you never present the secret. Maybe you lost it, or maybe you just decided not to use it. What happens? Nothing. The commitment just stays there on-chain, forever, unrevealed. And here's the kicker. No one can ever figure out what that secret was. It's a permanent digital black hole. And this isn't a bug in the system, it's a fundamental privacy feature.
So this creates this really clean, really sharp separation of data. Let's be super clear about what lives where. On-chain, the stuff everyone can see is just the commitment hashes and something called nullifiers, which is just proof that a commitment has been used. That is literally it. Everything else, your actual secrets, your data, the valuable stuff, that's all off-chain. It's private, it stays with you, and it's your responsibility.
Okay, so that's the how. It's a really powerful piece of cryptographic tech. But what's the so what? What can you actually do with this? What kind of new things does this power unlock in the real world? Well, for one, you get value that cannot be frozen. Think about it. If your assets are just these opaque commitments on a public ledger, no third party, no bank, no government can even identify what you own. And if they can't see what you have, they can't stop you from using it. For another, you get access that cannot be revoked. Imagine, say, a service gives you a one-time access token. Once they've given you that secret, that's it. They can't take it back, they can't disable it. You, and only you, hold the power to decide when, or even if, you ever use that access. And here's a big one: credentials that cannot be leaked. You could prove you have, say, a university degree or a professional certification without ever uploading the actual certificate to some company's server. You just prove you hold the secret that corresponds to it. And since that credential is never stored centrally, in the event of a data breach, there is literally nothing to steal. And you've got to see that this goes way beyond just cryptocurrency. We're talking about the potential foundation for things like a truly private digital identity, or voting systems that are both verifiable and anonymous, or think about supply chain verification, secure healthcare credentials, even something wild like a dead man's release, where a secret is automatically revealed only if you, say, stop checking in. Okay, this all sounds incredibly powerful, and it is. But you know the saying, with great power comes great responsibility. And in this case, great risk. So for our last section, let's bring this back down to earth and talk about the trade-offs and the reality of where this tech is today.
The trade-offs here are huge. With this kind of extreme power comes extreme responsibility. Let me be blunt, there are no safety nets. If you lose your secret, your commitment is gone forever. Poof. There's no forgot my password link. There's no administrator you can call for help. The system is designed so you don't have to trust anyone, which also means there's no one who can save you. The code is the law, period.
And it's really important we're clear about the current status of this project. Right now, according to the paper, the network is operational, but it's a testnet. The tokens have no real-world value, the contracts are unaudited. The creators themselves are calling it functional, but also very early and still evolving. So to be clear, this is cutting-edge experimental stuff.
I want to leave you with this final quote, because I think it just perfectly sums up the sheer ambition here. Ghost Protocol is not a promise of privacy, it is a mechanism that makes certain kinds of surveillance mathematically impossible. See, this isn't just another company making promises about keeping your data safe. This is a tool designed to create a reality where certain kinds of data simply don't exist to be surveilled in the first place. And that leaves us with a pretty big question to think about. What does our digital future even look like when our most important secrets can't be found? Not because they're well hidden, but because for all intents and purposes, they just aren't there.